Kia and welcome to this lesson on our external chance and data. 60 minutes for the whole thing. It's 3 questions, so you want to spend no more than 20 minutes on any individual question. Here we've got some time series data on population of a bird, population on the y-axis, the year along the x-axis. So this is time series. You see a repeating pattern year after year. Question asks, when was the lowest number recorded? Not how many, but when. So the lowest was definitely January of 2017, and we know that because it's the lowest point on the graph. One thing you should do when you're going through this practice one, have a look at the model answer, see how you did, and you'll also know what you need to get achieved merit or excellence, okay? Next part, same graph. Discuss any trends, regular patterns, and unusual features you notice. Provide evidence from the graph to back up your statements. Providing that evidence is going to be what's needed to get to higher levels of understanding. So for starters, regular patterns. Well, we do see a repeating pattern here. It seems like every year we see because this is January to January, we do have one of those per month. So it looks like every February or so, the population spikes, it levels off, if not drops a tiny bit over the next few months. And then we see a big drop off back down till, I guess if that's January, December, November, October or so. And that will be our repeating pattern. Unusual features right in there. You'd want to say how rather than leveling off near the end of the year, we have a very steep drop off. You're willing to speculate why. That is fine. And as far as the checking of the answer, you're going to see some long-term trend, regular patterns, unusual features that you'd want to discuss. And these are what you need to do to reach achieved merit and excellence. Okay, back to the question. Let's go to the next part. Okay, some of those birds will not move to other areas because they're too sick or too old. What's the probability that a female, what is the probability that is a female that stayed? Females are this row that stayed, 165. Now it doesn't say given that it's a female or if it's a female, so we're looking at 165 over 1350. Okay, 135 over 1350, always a good idea. Change it to a decimal, round it to 4 decimal places. Okay, next one. Okay, what is the probability? One of those selected. What is the probability? It's a male. Okay, similar kind of question, but different numbers. Let's go to the next question. Okay, is it a male or female more likely to move away? So there, you're going to want to compare both responses. The probability it's a female that moved away, 690 over 855. Change it to a decimal. The probability a male moved away, 410 over 495. Change it to a decimal. Reason we do that is it's much easier to compare these. So since the males is a little bit of a higher number, we can conclude it's more likely that the male is the one that moved away. And the next question, I'm going to pause it there and come back for this one. Okay, next part of this question, we've got some box and whiskers on the weight of humpback whales by gender. A student comments that the box of the female humpbacks is wider than the box of the male humpbacks. Interpret what this means. We should remember when we've got a wider box, that's going to mean that the middle 50% is simply more spread out or less consistent. The male has a smaller middle 50%. That means that the middle 50% were more consistent or less varied. We would type that in, checking our answer for that. Yep, greater variation or spread in the weights of the middle 50%. Thanks for watching. We'll be back with some more on this practice test.